Hey guys, welcome back to AlgoYogi. We are doing array and hashing series, and our next problem in the list is number of students unable to eat lunch. It's a sad problem, right? All right. So this school cafeteria offers circular and square sandwiches at lunch break, referred to by numbers 0 and 1, respectively. All students stand in a queue. Student either prefers a square or a circular sandwiches. Now the number of sandwiches in the cafeteria is equal to the number of students. All right. The sandwiches are placed in stack if the student at the front of the queue prefers the sandwich at the top of the stack, then they will just take that sandwich and leave the queue. Otherwise, they will leave it and go to the queue's end. This continues until none of the students in the queue want to take the top sandwich and thus are unable to eat. So it's just a matter of choice. Nobody's dying hungry here. The students have a choice, and if all the students in the queue want either if all the students in the queue want, let's say, a circular sandwich, but on the top of the stack is just it's a triangular, it's a square sandwich, then they're not going to take it. So that is why all of these they can't eat. All right, so that is actually the number that we will be returning. So this continues until we have read this. You are given two integer arrays, students and sandwiches, where students at the ith position is the type of the sandwich in the stack, and that is basically the top is the preference of the jth student. We already know this. So now we need to return the number of students that are unable to eat. We understand the problem, but let's go over it again. We are given students and their preference either 0 or 1. Let's say 0 represents basically a square sandwich, and or 0 represents a circular sandwich, and 1 represents a square sandwich. All right. Now there are basically 4 students in this case, and there are 4 sandwiches. Now what's happening right now is these sandwiches. So if I want to give like a picture of it to you guys. So this is how it's placed. It's in the form of a stack. So 0 1 0 1. So this is how it is. I've just like taken this this array and I've just put it vertically. So this is still the front, 0th index and 1th index and so on. Okay, now this is the queue of the student. So I have this queue where I have this student as 1 1 0 and 0. All right, this is what I have. So these are the students and their preference of the sandwich they want. So let's say if I'm in the front of the queue and this is on the top of the stack, these are the sandwiches. Now what will happen is, so I'll just write it students. So I'll just write this thing students, and this is sandwiches. So the front of the queue, the student in the front wants a square sandwich. It wants the sandwich that is the kind of 1, but on the top it's 0. So what will happen is this guy will go to the back of the queue. So I will actually open this in such a way it's easy for us to transfer these students to the back of the queue. So this guy will go to the back of the queue. So this will come over here, and now this is my new queue. Okay, now again the top of the stack is still 0 and front of the queue is 1. So that is why this guy will also go to the back of the queue. This guy will come here. Okay, so now I'll just get rid of this guy. So I'll just remove this, and then now you can see it's 0 in the front of the queue. So this guy will pick this sandwich and just leave the queue. So this guy will leave the queue. they will leave the queue. Okay, I'm just going to delete both of these guys. So I will delete this sandwich. This sandwich is gone. The guy in the front has taken it. Now the front of the queue is 1. Front of the top of the stack is 1. Front of the queue is 0. So they don't match. This guy doesn't want basically this square sandwich. So it will go back to the queue, back of the queue. It will come right here. And then now front of the queue is 1. Top of the stack is 1. This guy will take the sandwich and go away. So this sandwich is gone now. Now this guy is in the front. 1 is in the front. I'll just put these guys a little close to the sandwich. So top of the stack is 0. Front of the queue is 1. Do not match. So this guy will be sent back. So it will come here. So front of the queue becomes 0 now. Top of the queue is still 0. So this guy will take this sandwich, go away. So I will remove this from here. Now the top of the stack is 1 and there is only one guy left and it wants 1. Top of the stack is 1. Now they will also go away. This guy also receives a sandwich. Now what do I return? I was supposed to return the number of students, but now all the students actually were able to, eat all the sandwiches. So what must have happened? What must have happened in this scenario? What really must have happened is the amount, basically the number of ones and the number of zeros must have been equal. Don't you think so? Because I can still send any number of students to the back of the queue until everyone receives that number of that type of sandwich. But that will only be possible if you just have the logic, apply the logic that it is only possible if there are at least that many number of sandwiches that these students want. So what I'm trying to say is, so number of zeros and number of ones must be equal in students and sandwiches. So here the number of zeros, so number of ones is 2 and number of zeros is 2. And if you see in here as well, the number of ones are actually 2 and number of zeros are actually 2. So that is why it was possible for all the students to receive the sandwiches. But let's say if we are given, were we given that the size of the sandwiches and the size of students will be equal? So it was given to us. If you see right here, the number of sandwiches in the cafeteria is equal to the number of students. So it was given to us. So simply what we can do simply is just count the number of zeros and ones in the students, and then what we can do is, there are two things that we can do. We can actually just count the number of zeros and ones inside my students, and then we run a for loop on sandwiches, and if there are students in the need of that kind of sandwich, then we will basically reduce the number of count for that type of sandwich. I hope you're getting it. Otherwise, what we'll do is basically we'll move forward to the next type of sandwich, and in the end what we can return is the total number of these type of students for the either zeros or ones. So what I'm saying is, what I'll do is I will count the number of students who want 1th. So what I'll do is I will create, let's say, student map. I'm just going to call it student map. So 1 is basically 2, and then 0 is basically 2 here. Then I will run over the sandwiches. So for S in sandwiches, so now for S in sandwiches, if basically this particular sandwich, it could be 0 or 1, if this S on the top of the sandwich and the students that might be needing this, that frequency, if that's greater than 0, so let's say if student map, if this kind of sandwich, if there are basically students that need this S is greater than 0, in that case I will basically reduce that count. So there is one less student of either 0 or 1, because that was able to find their own kind of sandwich that they prefer, and then that will be, you know, one student less that will not need. Otherwise what can happen is, in else case, what will happen is, now I have S on the top, but then there are no students in my sandwich, in my student map, that actually want that kind of sandwich. So I cannot remove that top of the stack. I don't want to remove it. I cannot, like, that's the definition of the problem. Like, I cannot remove it. So that is why I will break from here. I will break from here and I will return. And if I can call this SM student map 0 plus student map 1. So this is what I will return. So what, maybe, like, if I change this problem just a little, then we will be able to actually realize our scenario. So there were students. First student wanted square, and then all three wanted basically circular. Now our count is different. I'm changing our first example. So 1th count is just 1 and 0th count is just 2. So S on the top, 0 is on the top. Then I see that 0th count is 2. Sorry, 0th count should be 2. It should be 3. So 0th count is 3. That means I have a student that want basically this sandwich, current sandwich 0. So that is why I will reduce its count. To 2. Move to the next guy. That's 1. Now in my student map there is 1, so this will become 0. These two guys are done. Then I have 0 again. Then I will come right here, and then I see, yes, I do have a student that has, you know, the 0th count is still greater than 0. So I have this 2. So I will remove this 2 and make it 1. Now there is one student that want circular sandwich. Now I come, this is also done. Now I come to this guy 1. Now tell me, is there a student that wants a square sandwich, which is 1? 1 represents square sandwich. Well, I see, actually no, this is not greater than 0. This is equal to 0. That means what? On the top of my stack is this kind of sandwich, one kind of sandwich, but I do not have a student that actually want that, right? So I will, no matter how many times I send guys to the back of the queue, because that kind of student does not exist in my queue, then they will never be able to make it to the front of the queue. So that is the reason I will break in a situation where I have certain kind of sandwich, but in my entire student set that remains with me in my queue, there is not a single student that wants that kind of sandwich. So that is why I will return. Now, so that will be our approach, and it will be of time complexity big of n and space complexity big of 1, and this is because my space is only just 2 values. All right, only of 2 values. So let me switch the view and just code it. It's gonna be crazy simple. Great. So let's just code it up. So as I said, we're gonna have I can call it student map, and this is gonna be just you know, this time we can just simply use counter because just 2 values. So I'll just put students. So there are just either zeros or ones and their frequency. Okay. Now for S in sandwiches, if the student map does have student map does have student of this type, this s 0 or 1 greater than 0, then only I will reduce its count s by 1 else I will break. Why will I break? Because on the top of my stack there is either 0 or 1, but in my student map I could not find any student of that type in the entire remaining queue of this student. That is why I will break, and then I can just return the student maps 0. And I think when you are returning this, it's either this or this, so one of them will have some value and one of them will not have any value, so it will be 0. So it doesn't matter. For ease we can just write this 0 will be added to the another values, and at the end of the day you are returning the remaining student who have not eaten, who are unable to eat. So let's run this. I'm gonna zoom out, run this on our test cases, and yes, so let's submit our answer. It was a really easy way if you just like conceptually sit down and think like what's really happening. But maybe like if you're thinking like just from a very not a bird eye, like maybe just you're trying to dive deep into the details, then you might end up simulating a queue, although you didn't have to simulate a queue, right? Or you could simulate a queue and still like achieve the time complexity of big of n, but that will just make things more complicated. There is this easy way of solving this, and space complexity big of n. Honestly, what we could have done is we could have just counted these zeros and ones in both the student and sandwiches, and then we could just logically compare, like if there are like a certain number of ones, then that the number of ones that will receive the sandwiches from here, number of zeros will receive the number of sandwiches from here, and then whatever remains there, that is the count that you will be returning. That you can do easily also. So let's, oh no, sorry, space complexity I might have just written by mistake, because we are kind of like using space, but logically it's just 2 values. All right, so this is done. See you guys later in the next problem.